Okay, here we have this shower head like this, and it's connected to a pipe like something like this, and it has the shower head has 20 tiny little openings there to get a good spray. Each of them has a radius of 1 millimeter, and then it's connected to a pipe, and the pipe has a radius of zero point 0.8 centimeters. And they give us the speed of the water in the pipe, and we want to know how fast is the water exiting. Okay, so call this kind of like point, like one is in the pipe and two is kind of at the shower head here. Well, the amount of water flowing through the pipe has to be the same as the amount of water flowing out of the shower head, right? I have to have, I can't have water backing up somewhere. And so we can use the equation of continuity for the same volumetric flow rates on both of them, and see what the speed would be, right? So the volumetric flow rate we have is the area times the velocity, right? So this would mean that area 1 times velocity 1 would be equal to area 2 times velocity 2. Yes, so that way we have the same same flow through the pipe that we have out of the shower head. So for one, I'll just convert everything to meters here, just for the sake of we have to have the same units. And so area 1, this is pi r1 squared, right? Pi r1 squared v1 is equal to area 2 is, there's 20 of these, so it's going to be 20 pi r2 squared, and then times velocity 2, right? Because there's 20 of those little openings. So these pi's will actually cancel out, and we'll have velocity 2, which is the velocity out of each of these holes in the shower head. This is going to be equal to r1 squared over r2 squared v1, right? Oops, there's a 20. So it's going to be r1 squared v1 over 20 r2 squared. And so R1, this was the 0.8 centimeter radius, right? So this is going to be in meters. That's 0.008 meters. So this would be, and then squared times velocity 1, which is 3 meters per second, divided by 20 r2 squared. The radius is 1 millimeter, so this is 0.001 squared. Okay, and so we end up here with the speed that it exits. It ends up being 9.6 meters per second. So this is how you get it going much faster. You make the hole smaller. You have to have the same volume flowing out. So you have to have a smaller area. You have to have a faster speed, right? So just the continuity equation there. Of course, then it's possible that if some of them get backed up or something like that, they get clogged, then it's going to come even faster out of the ones that are open, right? So yeah.